my students, how are you today? So we are done with chapter 1, and in this session we're going to start with chapter 2. In this chapter we are going to introduce a new physical quantity that you have not seen before. This physical quantity is called the linear momentum. This quantity is very, very important, extremely important. It has many applications in physics. So linear momentum is something new for you. In grade 11S, we studied kinematics, we studied dynamics, Newton's second law especially. In this chapter, we're going أكيد to كمان repeat some concepts from grade 11. بس basically هيكون linear momentum هو ال most important thing in this chapter. So before we start, we have something from grade 11 that you should know. It's a recall from grade 11. When we study kinematics, you know the difference between kinematics and dynamics. Kinematics is the study of motion, while dynamics is the study of the causes of the motion. Okay, so there is a big difference between the two. So you have the motion, you study it as it is using the three kinematical quantities that you have studied in grade 11. We have the position, vector r, and of course, from its name, it's the position, so we can find the position of the particle at any time you want. And we have the velocity, which is the speed and direction, and you have the very important quantity, which is the acceleration. So these are the kinematical quantities that you should know. Of course, they are vector quantities. They have direction and magnitude. To go from the position to the velocity, we can do the derivative. So the velocity is the derivative of the position, from grade 11. So v is equal dr by dt, which is equal to r prime. It's the same thing. R prime in physics, derivative of the quantity with respect to time. Or if you have the velocity, you can find the position by integrating the velocity with respect to time. So r is the integral of v dt. So from v to r, you do the antiderivative. From r to v, you do the derivative. And for the acceleration, if you have the velocity, you can derive the velocity to get the acceleration. So a is equal to dv by dt, which is equal to v prime. And because v is equal to r prime, so v prime is equal to r prime prime. So هتكون r double prime, or d square r by dt square. This form أكتر شيء we use it in mathematics. In physics لأنه all the derivatives هن حيكونوا with respect to time, so we use prime. Okay, and if you have the acceleration, you need the velocity, you can integrate the acceleration. So again, from r to v derive, from v to a we derive again, double derivative from r to a. From a to v we integrate, from v to r we integrate. طيب هلا you know that how the ثلاثة quantities هن vector quantities, they have direction and magnitude. For example, the velocity v, it's a speed and direction. if v, let's say, is equal to 2i plus 3j meters per second. So this is the velocity in 2 dimensions. And if you have a particle moving in a plane, we need x, ox axis, we need oy. So we have I and j as 2 unit vectors. So v is written in terms of I and j. How do we call it vx? How do vy? So to get the speed, v is equal to radical vx square, which is 2 square, plus vy square, which is 3. So it will be 4 plus 9. It's radical 13 meters per second. Okay, so we can get the speed from the velocity by doing this formula. It's radical vx square plus vy square. So for any vector, if you need the magnitude, you can do the same thing. Radical x component square plus y component square. And the position vector r, it's the same as OM. If O is the reference point and M is the moving point, so we're studying the motion of M with respect to O. And let's say we have, this is O, we have x, y, and M is moving on this trajectory. So this is point M at a certain instant. So this is OM. هذا بنقول له vector R. So here the position of M as seen by O, or with respect to O. So if you have R as a function of time, you need to find the velocity you can derive. For example, let's say that R is equal to t square I plus 2tj meter. So this is called x. This is x and this is y. So actually t square here, it represents the abscissa of M, and 2t represents the ordinate of M, which is y. So to find the velocity at any time, we can derive with respect to time. So حتصير velocity is equal to v is equal to r prime. So we derive x first, it's 2t I plus derivative of 2t in terms, يعني, with respect to time is 2, so it's 2j meter per second. Okay, to get the acceleration A is equal to v prime. So we derive again. حتصير derivative of 2t is 2i, and derivative of 2, since it's constant, so it's 0. حتصير 2i meter per second square. You know that the unit for the acceleration is meter per second square. So these are very important, أكيد. So we might use it in this chapter. So please be ready for this. Now we have here another thing that we have to know. Recall for one-dimensional motion. So in physics, we have 3 types of motion. في عندنا كتير classifications for the motion. We can classify them as يعني the particle is moving on a straight line. يعني we say no, it's one-dimensional motion. يعني it can مثلا, for example, if a particle is moving on a horizontal line, it can be moving to the right or to the left. The particle can be moving on a plane, so we need I and J. So we have right, left, for example, if the plane is vertical, right, left, up, down. And it might be moving in space in 3 dimensions. So, or sorry, 3 dimensions. So حتكون X, Y, and Z. يعني we need unit vectors I, J, and K. No, we don't need the 3 dimensions. We need only the one-dimensional motion and 2-dimensional motion. In one-dimensional motion, أكيد it's a special case for the 2-dimensional motion. In 1 dimension, since it's moving on a straight line, so we need only the x-axis. So this is the direction for the x-axis, and we need, of course, the origin O. Okay? So any particle moving on this axis, we need to find its position. Instead of using R for the position, in 1 dimension, we use X. Why? Because R in 2 dimensions is xi plus yj meter. So in 1 dimension, we have only x, and this is the unit vector I. So we have only xi. There is no j. So since r is xi, طب ليه حنضل نقول r is equal to I, r is equal minus 7i, I is equal to r equal 5i, etc. So instead of using I, خلاص, we know إنه it's only I, so we use x. Okay? Now for the direction, and for the simplicity also, since r is here xi, we use only x, and x can be positive or negative. So x is not a scalar quantity. يعني in physics في عنا scalar quantities وفي vector quantities. السكيلر هني that don't have direction, مثل الماس for example, or volume. ما بنقول volume of the box is 5 meter cube to the left. So الvolume هي scalar quantity, it's a number only. الماس 5 kilograms, ما في 5 kilograms downward مثلا. So الماس, velocity, current, whole scalar quantities. الكرنت حتى فينا نقول إنه هو vector quantity بمحل معين, يعني إنه it has a direction. So الvector quantities هن عندهم direction مثل الفورس, okay, اللي نحن بنعرفها من grade 11. Force, it can be up, down, in, out, etc. The velocity كمان, a car is moving to the right, a car is moving to the left with velocity, blah blah blah. So to describe the direction, we can use the positive negative signs هون. So if the particle is to the right of O, من all x is positive. So if x is, let's say, 4 meters, يعني it's 4 meters away from O, in which direction? In the positive direction. If x is equal to -5, so يعني it's at a distance 5 meters from O in the negative direction. So we use a plus minus. لما نكون عندي one dimensional motion خلاص it's enough to use plus or minus to describe the direction. والnumber itself هو magnitude for this vector for this quantity. So the position هون هي vector quantity. It's not a scalar quantity. It can be plus or minus. The velocity, the same thing. If the car is moving to the right on this axis, for example, with a speed of 6 meters per second to the right, so it's v هي plus 6. If it's moving to the left, the speed, the velocity will be minus, for example, minus 6 if the speed is 6. So minus, يعني it's moving to the left, plus moving to the right. So هذه هي vector quantity. It's not a scalar quantity. You know, فيها it contains a direction. فيها two information. Plus or minus the direction. The number هو magnitude, which is the speed. So A acceleration كمان the same thing. If the car is accelerating to the right, يعني A is positive. Accelerating to the left, so A is negative. The same relations مثل two-dimensional motion. V, instead of saying V vector is dr vector by dt, so حتكون هي dx by dt, which is x prime. For the position, to find the position, if you have the velocity, we integrate. So x is equal to integral v dt. A, the same thing, dv by dt, which is v prime. وهي the same thing as d square x by dt square or double derivative. نحن أكتر شيء بنعوز x double prime و v prime. Okay? For v, if you have the acceleration, v is equal to integral a dt. أنا بنعرف ال acceleration والanti derivative هني ال opposite. Okay. We don't يعني need the examples for this. يعني نحن بنعرف إنه ال one dimensional motion في two special cases. في ال uniform rectilinear motion وفينا ال uniform accelerated rectilinear motion. بس لذكركم فيهم. ال URM هي its motion uniform يعني constant velocity. R rectilinear يعني on a straight line. Motion أكيد هي its motion يعني. So the velocity حتكون constant. Okay, so it's plus 10 على طول velocity يعني constant. Acceleration حتكون 0. يعني if there is no change in the velocity يعني acceleration is 0 because A is the derivative of V or the derivative of the constant is 0. For X يعني position at any time حتكون Vt plus x0. Okay. So how the three equations for URM نحن أكيد بتهمنا ال x equal vt plus x0 لأنه ال velocity constant we don't need it as a function of time. Here it's not a function of time. Acceleration is 0. For UARM it's uniform accelerated rectilinear motion. يعني ال acceleration is constant. The acceleration is constant. So velocity v is equal to at plus v0. إذا نذكر إنه ال v0 هي the initial velocity. يعني ال velocity at time t equals 0. If you derive this side حتصير v prime and this side a is constant. So a times t derivative is a. So v prime is a plus this is constant so derivative is 0. So a is equal to a. يعني this is correct. طيب position x is equal to half a t square plus v0t plus x0. Okay, so this is the position of the particle at any time. So he t power 2. Okay, so this is the position at any time. If you derive this side حتصير x prime and this side حتصير half a times 2t, so it's at plus v0t يعني v0 derivative plus x0 لأن it's constant. هي initial position حتصير 0. So we'll get this equation if you derive both sides. So هذه الايكويشن فينا نطلع الايكويشن 2 from this equation. وهون if you derive حتصير a equal a, so يعني a is constant على طول هي it has the same value. واكيد في عندنا other equations for the UARM motion هو derived من هود التو equations. يعني we can مثلا find t in terms of v we substitute in x. فينا نرجع لهم بجريد 11 واذا بدنا نعوزهم موجودين هون. Okay, now we go to the linear momentum. Linear momentum, as we said, it's a vector quantity. It's a new physical quantity ما شفتوها قبل. Linear momentum لا من إلا linear from motion on a straight line. لأنه بتشابتر 3 في عنا angular momentum we use it in rotation. هيدي 4GS نحن مش مطلوب منها chapter 3. So linear momentum لأنه في angular momentum. So نحن من إلا linear momentum أو simply momentum. The linear momentum of a particle of mass m. كdefinition. Linear momentum of a particle of mass m and moving with a velocity v is given by p equal mv. So this is the symbol for the linear momentum. It's p vector equal to m times v. So if you have any object that has a mass m and moving with velocity v, so its linear momentum is simply m times v. So here, as a definition, linear momentum is very easy to define or very easy to find. يعني نحن we are familiar with the velocity. ما عندنا مشكل مع velocity. So we multiply it by the mass of the object. خلاص حنحصل على linear momentum. بس importance of the linear momentum حنشوفه later in this chapter. Okay? As a definition, it's very simple. Mass أكيد it's measured in kilograms. velocity نعرف SI meter per second. So حتصير اليونت for the linear momentum كيلوغرام meter per second. اوكي ما عندنا يونت يعني 1 مثلا مثل الفورس هي نيوتن وفينا نقول هي كيلوغرام meter per second square لانه الفورس هي mass times acceleration وماس in كيلوغرام acceleration meter per second square. So الفورس هي كيلوغرام meter per second square. نحن بنشيلهم بنكبهم بنحط نيوتن. So هون المومنتوم حتضل كيلوغرام meter per second. طيب since P is a vector quantity and P is mass times velocity. So if this is a particle moving with velocity v شايفين انه it's moving to the right with velocity v. So P حتكون عند the same direction as v. يعني نحن بنعرف انه الفيلوسيتي هي it represents the direction of motion. يعني بس نقول نحن الكار يعني how is it moving in which direction due north due south. فنعرف من الفيلوسيتي يعني الفيلوسيتي حتكون due north if the car is moving due north due south if it's moving due south. So المومنتوم the same thing لانه هي it's a positive value times v. So أكيد ال P and V حيكون عندهم same direction لأن هي ال velocity multiplied by a scalar. So vector times scalar حيعطيني أكيد vector. وهون شايفين في كتير تلاميذ عندنا misunderstanding إنه ال P it's always greater than V وهذه أكيد it's wrong لأنه الماس M أول شيء ما فينا we cannot compare two physical quantities that don't have the same unit. يعني ال velocity meter per second المومنتوم كيلوغرام meter per second يعني it's different unit يعني different quantity. بس as a magnitude كل وحدة عندها scale. يعني أنا I can draw مثلا ال P هي smaller than V or greater than V ما إلها علاقة يعني. So ال P وال V بس you have to know أن عندهم على طول same direction. If this particle مثلا changes its direction of motion صارت ال velocity in this direction حتصير ال momentum in the same direction كمان. Of course here we have the coordinate system إذا بدكم ال O اللي هي observing the motion حتكون هي reference point. ال I هي to the right وال J up وال K هي out. Okay يعني it's like this. It's out of the board. Okay. So the velocity v can be written in terms of I, J and K if it's moving in 3 dimensions. In 2 dimensions حتكون in terms of I و J. وإذا كانت 1 dimension يعني on a straight line نحن we choose this straight line to be the x-axis. So حتكون ال v in terms of I only I. So ال P حتكون أكيد in terms of I. Now the linear momentum of a system of particles of masses هيدي كتير important وحنعوزها. Sometimes احنا بيكون عندنا system هي عبارة عن one particle و sometimes حتكون هي عبارة عن different particles يعني n particles 2 3 4 5 قد ما بدنا. يعني فينا نقول مثلا بالون. إذا عندنا بالون ال molecules of air inside the balloon هن they form a system of يعني millions and millions of particles. So هيدي system أكيد نحن ما حنفوت على الميكروسكوبيك level، بس إنه هيدي it's something يعني true إنه ال molecules of air inside a balloon they form a system of n particles مثل هيدا الشيء. So linear momentum of a system of particles of masses ما ضروري يكون ال particles عندهم same mass. So masses m1, m2, m3 لل mn and moving كمان with different velocities v1, v2, v3 is given by. So to find نحن ال momentum of any system that is formed of n particles بنقلها ps يعني ال momentum of this system simply هي ال sum of the momenta جمع ال momentum momenta sum of the momenta of all the particles يعني هي p1 plus p2 plus p3 plus p4 لل pn قد ما عندنا particles اللي حتصير هي m1 v1 plus m2 v2 plus m3 v3. So هذا example في عندنا 1 2 3 4 6 particles each one is moving in a certain direction يعني عندها velocity different from the other. يمكن يكون عندهم شيء two particles same velocity ما بيأثر بس in general different velocities و different masses. So نحن if you have the momentum of each particle we need to find the momentum of the system, we call it ps. We add the momenta of all the particles to get the linear momentum of the whole system. So basically حيكون عندنا نحن أكثر شيء in this chapter حيكون الموشن على straight line. So البارتكلز حتى هذا الشيء ما حنشوفه نحن. اوكي حاعطيكم example على هذا الشيء بس ما حنشوفه كثير بالاكسرسايز. أكثر شيء حيكونوا particles moving on a straight line يعني particles to the right particles to the left وكمان حيكونوا 2 maximum 2. So هون حيكون أكيد in terms of I and J if they are moving in this plane. So حيكونوا I and J. So المومنتوم حتكون in terms of I و J والK أكيد ما حنشوف أبدا. طيب this is an example how to find the linear momentum of a system of particles. عندنا consider 3 particles of masses m1 equal 0.04, m2 0.02, m3 0.01 and 3 different particles, different masses. The 3 particles are moving in a plane with respective position vectors. So هيدي ال R1 هي position with respect to time for the first particle, R2 for the second particle, R3 for the third particle. هيدي احنا شايفينها هيدا الشيء بجريد 11 بال 2-dimensional motion. طيب the motion is studied according to the frame of reference OI J. يعني عندنا أكيد ال O هي reference point و I و J 2 unit vectors اللي هن طالعين من ال point O. Part A, find the linear momentum of each particle in terms of time. So نحن we need the momentum لكل particle in terms of time, not at a specific time. So part A, momentum for the first particle P1 is equal to m1 times v1. Okay? So simply momentum, mass times velocity. Now we don't have the velocity, we have the position. To find the velocity, we derive r1 with respect to time. So this is equal to m1 times the derivative of r1. So it's r1 prime equal. m1 is 0.04. It's written in the SI unit into r1. This is r1 derived with respect to time minus 2t square حتصير minus 4t. أكيد ما حنتعلم derivative إن إحنا بنعرف derivative كتير منيح. Minus 4ti plus derivative of this with respect to time 2t is 2 1 0 لأنه constant so حتصير 2j equal 0.04 times minus 4 0.16 minus ti plus 0.08j. أكيد اليونت كيلوغرام متر per second لأنه هذه velocity meter per second. This is the mass in kilograms. Now P2 the same thing, it's equal to m2 times v2. So it's m1 m2 r2 prime equal m2 is 0.02 times r2 prime derived with respect to time. For t it's 1, 2 is 0, so it's I minus the derivative of 1 is 0 minus 2tj equal it's 0.02 I minus 0.04 tj. J. So أكيد kilogram meter per second. Now for P3 it's M3 times V3. It's equal M3 R3 prime. M3 is 0.01 times derivative of R3 minus T cube هتصير minus 3T square I. Derivative for 1, the coefficient of J هي 0, so it's minus 3T square I equal minus 0.03 T square minus 0.03 T square times I kilogram meter per second. So this is the momentum for the first particle in terms of time. Here it's a function of time. This is P2 كمان a function of time. P3 a function of time. إذا ما طلعت function of time أوكي يعني بتكون هي it's not a function of time بتكون constant ما في مشكلة. طيب part B بيقول لي what is the linear momentum of each particle at t equal 1 يعني هو بده linear momentum على time equal 1 بس we substitute. So P1 at time 1 فينا نقول it's P1 of 1. هون كنت في احط P1 of t يعني as a function of time ما بأثر يعني. So P1 of 1 يعني هي المومنتوم at t equal 1 we substitute هيدي 1 حتصير minus 0.16 I plus 0.08 J kilogram meter per second. For P2 at time t equal 1 equal كمان we substitute 0.02 هيدي ما فيها time I minus 0.04 time 1 J kilogram meter per second. For P3 of 1 is equal to, this is the momentum of particle 3 at t equal 1 حتصير 0.03 t square يعني 1 square I kilogram meter per second. So now we found the momentum at t equal 1. Now in part C, deduce the total linear momentum of the system of 3 particles at t equal 1. So نحن عندنا 3 momenta at t equal 1. To find the linear momentum of the whole system at t equal 1 مثل ما قلنا قبل linear momentum for the system هي sum of the momenta of all the particles. So it's P1 plus P2 plus P3 لأنه عندنا نحن only يعني بس 3 particles. So ال P حتكون فينا نحن نعملها. ال P هي P1 plus P2 plus P3. أكيد we add ال I يعني coefficients of I يعني minus 0.16 plus 0.02 minus 0.03. So إذا بدنا حنقول ال P as sum of the 3 minus 0.16 0.02 0.03 حتصير minus 0.17 هيدي minus 0.01 و minus 0.16 حتصير minus 0.17 0.08 minus 0.04 يعني هي 0.04 وبال P3 ما في J so حتصير plus 0.04 J kilogram meter per second. So هيدي ال total momentum of the system. حنشوف هلا بالnext video حنشوف انه شو يعني ال total linear momentum of a system. يعني اوكي انه نحن جبنا التوتال يعني انا بنعرف انه المومنتوم لل1 ولل2 لل3 بس المومنتوم للسيستم طلع عندي 1 مومنتوم انه what does it represent اصلا. So هيدا حنشوفها ب next video و see you. يعطيكم العافية.